I'm going to show you exactly how to deal with joint probability density functions, how to calculate marginal probability density functions given a joint, as well as assessing independence of the involved random variables, as well as calculating probabilities that involve those random variables. Okay, so I have 5 questions, question A to E, lined up for you, and I'm going to go through the solution and explain as I go what I'm doing and why that is the correct method. Okay, so the setup of the question: 2 components of a mini computer have the following joint probability density function for their useful lifetimes x and y. F of x and y, that's the joint PDF, is equal to x e to the negative x times by 1 plus y when both x and y are non-negative and 0 otherwise. And then we have the question: what is the probability that the lifetime x of the first component exceeds 3? Okay, so we were only given a joint PDF, but we want the probability involving only x. So what we essentially have to do is take into account all possible values that y can take on. Now, the reason why I'm saying this is because I know both x and y belong in this positive region, or rather non-negative region, because they can also be 0. So I know they live somewhere there, and I just want to know what the probability is that x is greater than 3. I didn't say anything about y, so I have to take into account y over this whole line. So I need to set up a double integral. Okay, so the first integral is going to deal with y, so I can take y into account over all its values from 0 to infinity. I'm integrating over this joint probability function, and I'm integrating that in terms of y first. Now I integrate in terms of x, and I go x from 3 to infinity. Okay, and this is the probability that x is greater than 3. Okay, so now I need to solve this. Okay, so I substitute in this function in here, and if I do so, I have x e to the negative x into 1 plus y. Okay, now integrating in terms of y, I treat x as a constant, so I can take this x out of this first integral as such. Okay, then it's also helpful to distribute this x into this brackets, because I only want to deal with y here. Okay, so doing so, I should get negative x minus xy. Now that splits into negative x times by e to the negative xy. Okay, now e to the negative x is purely in terms of x. I can take that out this integral as well, so I do so. And now I actually have a relatively simple integral to solve in terms of y, just treating x as a constant. Okay, so this is still from 3 to infinity x e to the negative x, and then integrating this in terms of y, I have e to the negative xy, and I divide by the derivative of the exponent, so that's the derivative of negative xy, so I divide by negative x if I'm deriving in terms of y, and I'm integrating that from 0 to infinity, and this whole thing is integrated in terms of x afterwards. Okay, so how do I solve this? Okay, so I go from 3 to infinity x e to the negative x. If I substitute in infinity here for y, we'll have e to the negative infinity essentially, although obviously that you can't get that, but we'll have e to the negative y as y approaches infinity, and that'll approach 0. So I have here 0 minus, and then when I substitute in 0 into this expression for y, I'll get minus 1 over x times by e to the 0. Anything to the power of 0, that's just 1. Okay, and I'm integrating that in terms of x. Okay, so those negatives cancel, become a positive. This 0 can fall away. And then this x and this x will cancel. So now I have to integrate from 3 to infinity e to the negative x dx. So this is a much simpler integral to solve now. It's just negative e to the negative x, and I'm doing that from 3 to infinity. So if I substitute an infinity for x here, which obviously you can't do, you essentially actually substitute in t and take the limit as t goes to infinity. But we're getting you get the point. So that becomes 0. So we have 0 minus e to the negative 3. And this becomes e to the negative 3. And if you type that into your calculator, you will get 0.04978, etc., which just rounds to 0.05. Okay, now we check our answer, 0.05. Okay, that's correct. So let's move on to this next question now. So I've just kept the setup here the same, just so that we don't have to keep scrolling upwards. Now the question is, what is the marginal PDF of x? So this means I have the joint PDF and I just want the PDF of x. I don't want y to be involved here. So what do? I simply integrate out y. I integrate over all the range of y so that I can eliminate it from this expression. So I'm finding the PDF of x, and that's going to be the integral over y's range or domain fx of y dy. Okay, and I'm integrating in terms of y so that whatever y is in here gets integrated out, becomes a constant. Okay, so what I'm doing then is I'm integrating from 0 to infinity because y's range is greater than or equal to 0. And I substitute in the PDF, so I get x e to the negative x 1 plus y, and then dy. And then this is much like what we did over here when we integrated in terms of y. And what essentially happens is we end up with e to the negative x eventually when we've solved the integral and all these subbed in all the bounds. So we just end up with e to the negative x here. So I'm not going to do it again because it's the exact same integration. So we left with e to the negative x. So essentially what I've said here is, if you look at this integral, it's 0 to infinity of the joint PDF in terms of y. If you look over here, that is the integral of 0 to infinity in terms of y, and it's the joint PDF. So this e to the negative x, remember I took it out because it was not in terms of y, so we'd end up doing the same thing as well. Okay, so this is just e to the negative x, but don't forget to define where x can be found. So x is found greater than or equal to 0. Okay, and that is the marginal PDF of x. Check our answer, e to the negative x on this range or domain. Yes, okay. So we move to the next question. Slightly harder integral. I encourage you to try it for yourself first. So two components are, this is setup of the question again. And now we have to solve the sub-question C. What is the marginal PDF of y? Okay, so once again, what we're going to do is integrating the joint PDF, f of x and y, in terms of x now, so that we can integrate x out, so x becomes a constant. Okay, and x is defined from 0 to infinity. Okay, and then I can just substitute in this, and I get x e to the negative x into 1 plus y. Okay, so I'm going to use integration by parts to solve this. So the part that's easier to differentiate is just x, and if I differentiate that, it's just dx. Okay, and then the part that's easier to integrate is e to the negative x 1 plus y dx, and if I integrate that, in terms of x, I get e to the negative x 1 plus y, and then I divide by the derivative of the exponent. So the derivative of negative x times by 1 plus y in terms of x is just negative into 1 plus y. Okay. So now I can express this integral as u times by v. So that's negative x over 1 plus y e to the negative x into 1 plus y. And that I integrated from 0 to infinity. And here I'm subtracting v du. Okay, so that's this expression dx times by this. So I have negative 1 over 1 plus y e to the negative x 1 plus y dx. Okay, and those negatives cancel, so I'm just left with a positive outside here. I'm integrating this in terms of x. Okay, so I'm going to take out this 1 plus y. And also now be careful. The bounds here were 0 to infinity, so I have to maintain those. 0 to infinity. I can take out this 1 plus y, since it's a constant with respect to x. Put it outside there. And now I'm simply integrating that, which I'll do in this next line. Okay, so let's substitute in quotation marks infinity into this expression for x, because we integrated in terms of x. Okay, so we'll have x in the numerator and e to the x in the denominator. So e to the negative x, just 1 over e to the x, and e to the x will go to 0 much faster than x will go to, or will go to infinity much rather faster than x will go to infinity. And so our first one is 0. And then we subtract this expression evaluated at 0 for x. So e to the negative 0 times by whatever, that just becomes 1. And this x will take the rest of the expression to 0. So 0 minus 0. Okay, now I have 1 over 1 plus y. And I'm integrating this in terms of x. So I have e to the negative x 1 plus y. And then I'm dividing by the derivative of the exponent. Okay, so that is minus 1 over 1 plus I, and that goes from 0 to infinity. Okay, so now I'm evaluating this expression here, and then this expression, if I substitute in, again, in quotation marks, infinity for x, that's just 0, and then if I substitute in 0 for x, and I'm subtracting this expression evaluated at 0 from this expression evaluated at infinity, I get 1 over 1 plus y into 0 minus 1 over 1 plus y e to the 0, which is just 1. And then these negatives become a positive, and then I'm just left with 1 over 1 plus y times by itself, so 1 over 1 plus y squared. And so that's fully in terms of y now. So I've evaluated the marginal PDF of y, and I remember that y is defined for y greater than or equal to 0. Okay, so let's check our answer, and it is correct. Okay, so let's move on to this next question, question D. So are the two lifetimes independent, and explain? Okay, so what would make them independent? They would be independent if the product of their marginal PDFs equated to the joint probability density function. So what were their marginals? Well, I'm basically looking for f of x times by f of y. F of x, if you remember correctly, was e to the negative x, and f of y was 1 over 1 plus y squared. Let's check that's correct. Yeah, 1 over 1 plus y squared for f of y, and f of x, it was e to the negative x. Okay, so e to the negative x times by 1 over 1 plus y. Does this equal to x e to the negative x into 1 plus y? Well, clearly not. Okay, so that's not true. So if we follow this, line, we see that f of x times by f of y does not equal to f of x times y. So they're not independent. Okay. And let's see if we correct. Yes. Okay, so it says no, the joint does not equal the product of the marginal, so they're not independent. Okay, so the last question now. What is the probability that the lifetime of at least one component exceeds 3? Okay, so I need to write this now in terms of both of the random variables. So I'm looking for the probability that x is greater than 3 or that y is greater than 3. So there's a number of ways that you could do this. I'm going to show you one of the ways. So what I'm going to essentially say is that I'm looking for either x greater than 3 or y greater than 3. So in other words, I'm looking for 1 minus the probability that x is less than or equal to 3 and y is less than or equal to 3. Okay, so why is that true? Well, let's draw our diagram here. They're both defined from 0 to infinity, and I'm looking for that one of them lasts somewhere there, x or y. So one of them lasting there is the same as, so this one takes into account everything, and then this x less than or equal to 3 and y less than or equal to 3 means that both of them must be in there. So this greater line minus this smaller line equals the probability that we're trying to find. Okay, so I've just re-expressed this in terms of this here. Okay, so this here is defined, is in terms of the joint density. So I can now integrate over the joint density. I couldn't do that for or, I can do it for and though. Okay, so this becomes 1 minus the double integral over this joint probability density function, xe to the negative x, 1 plus y. And then we're going to integrate this first in terms of y, and then next in terms of x, and then we're integrating from 0 to 3 for both y and x, because they must both be less than or equal to 3, and they both exist only greater than or equal to 0. Okay, so 0 to 3. So now all that's left is just solve this integral. So we have 1 minus the integral from 0 to 3, and then this here is the integral in terms of y. So I can take out everything that's in terms of x because it's a constant with respect to y. So I have x e to the negative x out here, and then I'm integrating from 0 to 3, e to the negative xy, and that's dy dx. Okay, so 1 minus the integral from 0 to 3, x e to the negative x. And then this here, integrated in terms of y, is just e to the negative xy, 1 over x, negative 1 over x, from 0 to 3, and this in terms of x. Okay, so now I have to substitute in 3 here for y. Okay, so I have 1 minus integral from 0 to 3, x e to the negative x. Now, I have minus 1 over x e to the negative 3x. And then I evaluate this expression at y equals to 0. And that's just e to the negative 0, or e to the negative x times 0, which is e to the 0, which is 1. Okay, so minus 1 times by negative 1 over x, so it's minus 1 over x, and those two negatives become a positive. Okay, now this x here will cancel when distributed with both of those, so I'm going to cancel those out, and then I have 1 minus, okay, and this is integrated in terms of x. Okay, so from 0 to 3, I distribute this e to the negative x into this e to the negative 3x, which becomes e to the negative 4x, and then that's a negative sign outside, because of this one, and then times by positive 1. Okay, so that's plus e to the negative x. Then I'm integrating that in terms of x. Okay, so that's two separate integrals that I'll solve. So this is 1 minus, evaluating this integral, it's just e to the negative 4x minus 1 divided by negative 4, and that evaluated from 0 to 3. Now let's make sure we don't get all the negatives confused here. So we got to be careful with brackets. Okay, and then integrate that from 0 to 3. It's just negative e to the negative x from 0 to 3. Okay. Yeah, and let's just make sure we haven't done something silly here. Okay, so we integrate this. The negative 1 stays, okay, yeah. Integrate e to the negative 4x stays. We divide by the derivative of the exponent, negative 4, that's fine. Integrating that from 0 to 3. Okay, then this next one, the integral is negative e to the negative x, and we integrating from 0 to 3, and then we have this negative outside that's distributing into everything, so it makes sense. Okay, now these two negatives will cancel, become positives, and it's 1 minus this here evaluated at 3, so it's e to the negative 12, because 4 times by 3, 12, and then minus, sorry, this is 1 over 4 too, okay, and then we have 1 over 4 times by this, where x is evaluated at 0, so it's just 1 over 4 times by e to the 0, which is 1 over 4 times by 1. Okay, then we evaluate this. Okay, so that is negative e to the negative 3, and then this evaluated at 0 is e to the 0, which is 1, but I subtracting it, but it's already negative, so it becomes now positive 1. Okay, so now we can distribute this negative outside into all of these terms. So I'm going to get rid of those brackets. This became a negative. This will become positive. This will become positive. And this here will become negative. Okay, so that 1 and that negative 1 will cancel. Then I have all of this, which you can type into your calculator. So if you go ahead and do that, you have 0.25 or 1 over 4 negative 1 over 4 times by e to the negative 12 plus 0.25 plus e to the negative 3, and when you evaluate that you get 0.29978, etc., which just rounds to 0.3. And now we check, final question, did we get it right? Yes. Okay, I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to the channel.